So here we are. So we have an image that is front of us. Basically, if you've seen the basically different type of mineral like the magnesium, chlorine, iron, and sodium, they are obviously found on in our crust, and obviously that the rock, that combination of this. Magnesium, chlorine, iron, and sodium. They are obviously this crust particles or the structures, we can call it as rock. But when there is a single we can say the minerals in abundance, like for example we have taken the yellow line for the iron, the purple line for the sodium, the green line and the green line for the chlorine, black line for the chlorine, and the orange line for the magnesium. And when there is abundance, like the abundance of the magnesium, evidence of the iron, like the yellow line, and then particular rock, if there is much abundance and there are many yellow lines in the second one, then obviously that rock is probably known as the ore, and obviously the yellow line represents the iron, so it is obviously known as the iron ore. Basically, what is the basic difference between a rock and a iron? The rock contains different kinds of mineral like the magnesium, chlorine, iron, and sodium that are probably found in the nature, but the ore is the one where is the abundance of that mineral. So that is the difference between a rock and an iron. And obviously we have seen different type of reaction now where we can find this kind of metals. And so obviously, like we know, the magnesium is a metal, chlorine is a non-metal, iron is a metal, and sodium is obviously a metal. So there are different kinds of metal that are found in the rocks. They at that time they are known as the mineral, and where there is abundance of a particular mineral, they are known as the ore. So this is where once again the iron. So here we can see there are some metal that are obviously found in the free state, like the gold and the platinum, and there are some metal that are found in the ore, like the copper and the silver. Obviously, they are in the rest reactivity. So the gold is obviously found in free state. The platinum also find this state, or some can be found in the ore format, like the copper and the silver. So like they are found in obviously in the free stages, but sometimes the copper and silver can be found as form. So they, if as we go down the reactive stages, then they can be found at pure stage. And we when we talk about the copper and the silver, they can be found in both combined and the free state. Oh, obviously we have seen the reactive series. So now the middle reactive materials, that is zinc, iron, and the lead. Obviously they are fine. They are mid reactivity, so they are fine in combined state, but also they can be reactive. So they react with sulfur and oxygen, like zinc sulfate, iron oxide, and the lead sulfate. And obviously often formed as sulfide ore in the hydrothermal veins extractions by roasting and apparently dark and black crystals. And iron, on the other hand, a major iron ore found in sedimentary rocks extraction is smelting in blast furnace with coke and limestone, appearance reddish brown. Where on the other hand, if we talk about the lead, then obviously it's primarily the ore often associated with the zinc, silver, and the copper, and extraction is by roasting and followed by smelting in the blast furnace, and heavy shining metallic cubic crystals structure and the grains that are found. So basically these are the medial reactive element that form probably bond with the sulfide and the oxides. Like the first of all, we have seen they are found either in the free stage or they are found in the compound ore form. And on the other hand, the middle reactivity, as they are middle reactive, they are reactive with the sulfide and iron and the oxide, sorry, or in form oxide or sulfates. And we are now going to see we classify this ores as the basis of the reactivity stage. So the lower most are either free stage or form the ore, and the middles are sulfide or oxides. And now we're going to see the furthermost, the most reactive. So if we see the last, that is the highly reactive metal, that is the potassium, sodium, lithium, and calcium, magnesium, and aluminum, they are found as ores. And obviously they are granulite, rock salts, salt, and limestone, lithium LS, Si2SO8, so sodium imine, and magnesite and bauxite. These are the ores they are found in the particular ore stage, the most reactive element, and they are most reactive. That's why they probably not found in ordinary state, they most probably react with other kinds of element. Like if we take the example of the potassium that react with MgC, water. If we take the sodium that react with chlorine, and because they are highly reactive, they always found in the combined state. And if we take about lithium, then it is lithium react with aluminium sulfate and the oxygen, and limestone then it react with calcium react with the carbon and oxygen, and magnesium is the carbon and oxygen sulfate with water. This is the element react formed with oxygen and water. So if we combine all that together, so the lowest smoother reactive they are the free state or formed at the combined O stage, and the middle reactive they find with the oxide and sulfur, and the third the most reactive they find with other kinds of element, but as the magnesium, aluminium, and different kinds of other compound they found as not a single form, but with the combination of many other elements that combined reactive with that element to form a combined O.